Hi everyone, today I'm going to go over section 1.4, which is elements, and I'm going to go over syllabus 23 through 30. To start, we have the intro to the periodic table. So the periodic table is made up of a lot of small squares, and each one of those squares has an atomic number, a symbol, and a mass number. And I wrote down an example for you, which is oxygen. And in oxygen, here is our symbol. Right here is our atomic number at the top, as always. And the bottom, right there, is mass number. And this is the same for every element. Alright, here's an example of two different elements and what their mass number, atomic number, and name are for you to fill out. So you can take a minute or so now to fill both these out. Pause the video if you like, or whatever you need. So our first one is carbon. The atomic number is 6, and the mass number is 12.011. The name for this one is germanium. Didn't make my line long enough. The atomic number is 32, and the mass number is 72.631. Continuing on with our intro to PT, some elements come in their Latin name, their old Latin name, which some examples of those are sodium, which is written as Na, which stands for natrium. And another example of that is copper, which is written as Cu on the PT, and that stands for cyprium. Okay, and then finally with the intro to PT, some elements use names that come from German. For an example of this is tungsten, which comes from the German word of wolfram. And we have groups and families on the periodic table. And to start, we have groups, which are the horizontal columns on the periodic table. Here's the diagram. They're numbered 1 through 18. An example would be group 1 are the alkali metals, which are right there. Then we have families, which they all have the same number of valence electrons, and they're mainly metals versus nonmetals, and they all share similarities, which makes them a family. Periods on the periodic table. These are the horizontal rows of elements on the periodic table. They have physical or chemical properties, and these properties are changing pretty regularly. Elements that are closer together or closer to each other, they are more similar. The regions of the periodic table. We have the lanthanide and actinide series, which are at the bottom of the periodic table. There's metallic elements that go underneath the periodic table to keep it from being too wide, or else it would extend out really, really far and not look good visually at all. There's metals versus nonmetals all over the periodic table, and nonmetals are always towards the right, while metals are always towards the left. There are metals on the periodic table. These are elements that are really good electrical and heat conductors, and they are ductile. They have a high tensile strength, and they are very versatile. Contrasting metals, they're nonmetals. which these have a poor heat and electricity conductors, unlike metals, and there are fewer nonmetals than metals on the periodic table, and nonmetals have a high ionization energies to them. After nonmetals and metals, we have metalloids, which are almost like the middleman of both those. These are elements that have some characteristics of metals and some characteristics of nonmetals. So kind of like both combined, taking out a few different characteristics, but similar things from each groups. Metalloids are solids at room temperature and they are semiconductors of electricity. Last but not least, for all the different parts of the periodic table, we have noble gases, which these are like hydrogen, radon, neon, etc. Noble gases are naturally occurring elements of group 18, and they are rarely reacting with other elements. And here's where they're located on the periodic table, all the way in this right-hand side. Those are all your noble gases. So helium, neon, argon, krypton, xenon, and radon are noble gases. Alright, here's our periodic table of elements. Just for a little recap, the metalloids are on this staircase looking thing right here, and they go down just like that. Some examples are boron, germanium, antimony, tellurium. Then our lanthanides are at the bottom chunk here. They're on the top of the bottom chunk. And then actinides are at the bottom of this chunk down here. So those two are stacked on top of each other. The alkali metals are all the way in the left corner here in the red. And then our noble gases are all the way on the right here in the pink. Our transition metals are in the center, which I didn't cover, but those are in the center. And then nonmetals can be found over here and also right here with hydrogen, kind of tucked away. So nonmetals, metals, and metalloids right there. Then all these down here just have unknown chemical properties, as it says right there.